The experiment we ran focused on generating XAI metric values and evaluating the different XAI metrics to determine how transparent they make a model. Our prerequisites for this project were: in order to install the requirements for our project, you must do pip install -r requirements.txt. After running this command, you must download the glove embeddings. This allows for language strings to be interpreted as numbers for the model. In order to do this, you must run python xai setup.py. Due to the time it takes to run the commands and complete the training, the metric generation, and the evaluation metrics, the commands would not be completely run, and therefore would just be showed instead of actually running. And keep it on your current folder directory. Following this is the training step. For training, we trained a convolutional neural network on the Stanford Natural Language Inference dataset. Two types of CNN models will be created: an initialized CNN model that will not be trained, and a trained CNN model that will be trained. A total of 5 CNN models for each model type will be created to produce a sample size for evaluation. In order to run the training step, we must run the following command: python -m models.train CNN. Following the training step is the generating XAI metrics. For metrics generation, we generate gradient, occlusion, lime, and shape saliency values. In addition, random saliency metrics are required to be generated that will be used in the next step. To generate the saliency values, the following commands must be run: python -m saliency gen interpret grads _ occlusion. This will create gradients and occlusion. Next is lime. In order to run lime, you must run the following Python command: python -m saliency _ gen interpret lime. Similarly, shape is run the same way by doing python -m saliency _ gen interpret shape. And lastly, random values are generated using python -m saliency _ gen generate random salience. After this is the evaluation step. We use 5 different criteria to evaluate each model based on their metrics: confidence, faithfulness, human agreement, data consistency, and rationale consistency. Saliency values for evaluate. In order to generate the values, the following commands must be run: python -m saliency _ eval .confidence for confidence values, python -m saliency _ eval .faithfulness for faithfulness values. Human agreement is the same way by just adding .human agreement instead of .faithfulness and .confidence. For rationale consistency, it's a little bit different. The following 2 commands must be run in order to generate rationale consistency values. The first command is a pre-compute command before running the actual saliency. You do python -m saliency _ eval .consistency pre-compute to pre-compute the values. Next, you do python -m saliency _ eval .consistency rationales in order to compute the rationale consistency values. Following this is the data consistency values. In order to generate data consistency values, we run the following commands: python -m saliency _ eval .consistent data, sample, and instance pairs to pre-compute the values. Next is python -m saliency _ eval .consist data to generate the data consistency values. Following this is the analysis step. The evaluations are now analyzed in order to generate an understanding of how transparent the model is, but also to evaluate how each metric interprets a model. Graphs are produced from the values in order to compare the values. In order to run the command, we do python eval _ analysis /analysis.python. This would create graphs based on the evaluation values. The following graphs are produced. First is the confidence graph, which shows the confidence values based on their mean for each metric, and the standard deviation for each metric. Similarly is consistency, which shows the mean of each metric and the standard deviation. Data consistency, which shows the mean of the data consistency and the standard deviation. Faithfulness is then run, and as we can see, it also generates the mean and the standard deviation, with SHAP values having the highest faithfulness of all the other values. Following this is lastly is human agreement, which similarly shows mean and standard deviation.